Hello grade 8 students. In this video we're going to introduce a new lesson which is square roots. So our objectives are to define a square root and how do we find the square roots of perfect squares, and then we're going to perform calculations with square roots. So let us first define what's the meaning of a square root. So the square of any number, you know that the square of any number is always positive. So like 5 square is 25, minus 5 square is 25, 7 squared is 49, and minus 7 squared is also 49, because the even exponent, it gets rid of the minus. Now we're going to search for the square root. Like for example, now I'm going to give you 25, and I'll be asking you of its root. So it's the square of what? So you have to tell me that it's 5. So now we're going to search for the roots of the numbers. So what are the numbers that you square them and you get this number? So the square root of a number, when you search for the root of the number, you put this radical A. So this symbol, it's called the radical, okay? The radical sign. And what's inside, it's called the radicand. Every time you have radical A squared, it's 8. So the square goes with the radical and we keep the root. So A is the root. Okay? Also, if you have parentheses outside, the 2 goes with the radical and what stayed is A, the root. Okay? So radical minus A does not exist because you cannot find a root. Okay. The root, it cannot be negative. Okay, so the radical cannot be negative number. It doesn't exist. So radical minus 16 doesn't exist, and radical minus 9 also doesn't exist. But if you have it outside, so if you have the minus here outside the radical, it works out because the radical itself, it exists. Its answer is A, and you have minus outside, so it's minus A. It's a positive number. Now the square roots of perfect squares. So as I told you before, radical A squared is 8. So every time you see like 36, it's the perfect square of 6. So radical 36 is radical 6 squared, which is 6. And radical 9 also, it's a perfect square. It's 3 squared. So the answer is directly 3. 64, it's also the perfect square. So you have to study those numbers. You should replace them directly. So it's 8 squared, which is 8. So every time the square is going to go with the radical, and what's left is the number inside. Now radical 100, it's radical 10 squared, so the answer is 10. Radical 1, 1 is also a perfect square of 1, so the answer is 1. Now what if the number that you have inside the radical, it's not a perfect square of something? So what do? The steps are very easy. First, you have to decompose the number into prime factors. Then you can get outside what's possible. Let us take an example. So we have radical 48. If you decompose 48, it's 2 to the power 4 times 3. So you know that 2 to the power 4, it's a perfect square of something. It's the perfect square of 2. So now you can replace 2 to the power 4 by 2 squared. So it's the perfect square of 2 squared. Now the squared goes with the radical, and what's left is 2 squared times radical 3, which is 4 radical 3. Now let us try another number like 72. You know that 72, when you decompose it, it's 2 to the power 3 times 3 squared. 2 to the power 3, it's not going to work out in this way because it's not a perfect square of something. So I'm going to split 2 power 3 into 2 squared times 2. Okay, so I splitted the odd exponent into perfect square plus odd. Now the perfect square goes outside as we did before, 2. Okay, and also 3 squared, it goes outside 3, but I have inside radical 2 left. Now 2 times 3, it's 6, so the final answer is 6 radical 2. Now let us perform some calculations with square roots. Like if we have a times radical b, it's written as a radical b. So if you have, like, for example, 2 radical 3, you have to know that it's 2 times radical 3. 3 times radical 7 is 3 radical 7. 10 times radical 3, it's 10 radical 3. We can only add and subtract similar radicals. Like, for example, if you have 5 radical 2 plus 3 radical 2, it's 8 radical 2. What did we do here? What we did is we add the coefficients. So 5 plus 3, it's 8. And we keep the same radical, which is radical 2. So here, if you have minus 3 radical 5 plus 2 radical 2 minus 5 radical 5, you search for the like or the similar radicals to add them or subtract them. Minus 3 radical 5 and minus 5 radical 5, it's minus 8 radical 5. And 2 radical 2 stays as it is because it's not similar to radical 5. Now we have 3 radical 2 into radical 5 minus 5 radical 2. Here you multiply. You can multiply different radicals, okay? So, sorry, radical 2 times radical 5, it's radical 10. Okay? And 3 radical 2 times 5 radical 2, it's 15 radical 2 squared. Because radical 2 times radical 2, it's radical 2 squared. So the squared gets rid of the radical. What's left, it's 2. Now 15 times 2 is 30. Okay? If the radicand is not a perfect square, we can find its prime factors using prime factorization. Then we can simplify. Another example, it's radical 24. It's 2 cubed times 3. As I told you before, you have to split 2 power 3 into 2 powers. Okay? You should split it into 2 squared, which is a perfect square, times 2, times 3. The 2 squared goes outside 2. And what's left inside, it's 2 times 3, which is 6. Also, radical 90, when you do prime factorization, it's 2 times 3 squared times 5. So here only the 3 goes outside because it's a perfect square, and everything inside left as it is. 2 times 5 is 10. Now let us reduce the following radicals. Radical 9, you know that it's radical 3 squared. It's a perfect square of 3, so it goes outside 3. Radical 4 over 25, you know also that 4, you can split the radical. Radical 4 over radical 25. Radical 4, it's 2 squared. Radical 25, it's 5 squared. So both of them are perfect square, so it's 2 over 5. 10,000, it's radical 10 to the power 4, so it's the perfect square of 2. 10 to the power 2, so it goes out 10 to the power 2, which is 100. Now 0.81, radical 0.81, it's 81 times 10 to the power minus 2. You change it into a whole number. Now 81, you know that it's a perfect square of 9. So, and 10 to the power minus 2, it's the perfect square of 10 to the power minus 1. So it's 9 times 10 to the power minus 1, which is 0.9. Now radical 15 squared, the squared goes with the radical, so it's 15. Radical 1 over radical 4, it's radical 1 squared over 2 squared, which is 1 over 2. Radical minus 10 squared, here it's not impossible because the minus goes with the even exponent, so it's 10. Also here the 15. Radical 0, it's 0. Radical 81, it's a perfect square of 9, so it's 9. Minus 7 squared, the minus goes because it's an even exponent. The square goes with the radical, so it's 7. Minus radical 36 squared, the minus also goes with the even exponent. And radical 36, it stays as it is because the square is going to go with the radical. Minus into radical minus 0.1 squared, it's minus 0.1 because the minus, it's outside. Now let us simplify. Radical 3 squared, it's 3. Minus radical 3 squared, it's minus 3. But because I have even exponent, it goes. Minus radical 9 is minus 3. Radical minus 5 squared, it's 5. And minus radical 5 squared, it's minus 5.